Good morning. All right, so starting with question number 1, our instructions are just to factor each completely. The first one has 3 terms, so we're automatically looking for a greatest common factor, which there is not one. And then since there's 3 terms, we're going to work through our asterisks. So remember, this number here is A, this number here is B, and this number out at the end is C. And then we're just following our formula for our asterisks, A, B, and A times C at the top. We're looking for 2 numbers to multiply to give us the top and add to give us the bottom. So if we fill out our asterisks, A is 1, so we're going to put that top left, top right. B goes in the bottom middle. Make sure you bring that negative down with the 8. And then for the top middle, we have 1 times negative 20, which is negative 20. So now I'm looking for 2 numbers that multiply to give me negative 20, but add to give me negative 8. That would be negative 10 and 2. Once I have my 2 fractions, I'm going to look at these and see if I can reduce. Remember, we talked yesterday, if the numerator or the top number of your fraction is a 1, you're not going to be able to reduce. So in this case, we can't reduce. We're just going to add our variables to the top. In this case, they're b's. And then we're going to write our 2 factors from those 2 fractions. So 1b minus 10, or just b minus 10. And the other one, b plus 2. Since it's a positive 2, we're putting plus 2. And that right there is my final answer. Question number 2, same process. A is again 1, B is negative 14, and A times C is 1 times 48, which is 48. So 2 numbers that multiply to give me 48 and add to give me negative 14, negative 6, and negative 8. If you wrote negative 8 first, that's okay. So then I'm looking at my fractions. Since there are 1s on top, I know I can't reduce. So I'm going to add my variables to the top and go ahead and write my factors. Excuse me. So 1n minus 6, which is just n minus 6. And 1n minus 8, which is just n minus 8. You are permitted to add those 1s in there. That's okay, but they're not required. Questions on these 2? So, did you get the same answer? Then you're good. So this is just how we teach it. There are other ways to do it. I was taught a different way when I was in school too. So that's fine. For questions 3 and 4, first thing I notice about question 3 and question 4, they are both 2 terms with no greatest common factor. So I'm automatically going to look for a difference of squares. I'm going to see if I can square root both terms because there's a minus sign in the middle. So I'm looking to get 2 sets of parentheses, one with a plus sign in the middle, one with a minus sign in the middle. 2 numbers that multiplied, well, the same number multiplied by itself to give you 25 is 5. Square root of n squared is n. Double check, is 5n times 5n 25n squared? Absolutely. The second term tends to trick people up. Remember that the square root of 1 is just 1 because 1 times 1 is 1. So 5n plus 1, 5n minus 1. Again, as always, order doesn't matter as long as you have both sets of parentheses. Very, very similar process on question 4. Again, two terms, no greatest common factor. We've checked it's got that minus sign in the middle. So I'm going to make my two sets of parentheses. One gets a plus sign in the middle, one gets a minus sign. Square root of k squared is just k. So k goes first in both of my parentheses. And then 25, when I square root 25, it's just 5 times 5. So final answer would be factors of k plus 5 and k minus 5. There's really no work you can really show with those, and that's okay. Questions on these two? All right. The last two are back to three terms, so I'm going to just quickly glance through to see if there's a greatest common factor. So you have 5, 11, and 6. I can't divide 5, 11, and 6 by anything, and there's not a k in all three terms, so I'm automatically going to my asterisk. A is 5, so I'm putting 5 and 5. B goes in the bottom, so negative 11 in the bottom. And be careful, the top middle, I have to multiply the first and the last numbers together. A times C, so 5 times 6 is 30. So now I'm looking for two numbers that multiply to give me positive 30, but add to give me negative 11. You got it. So negative 5 and negative 6. We're looking at our two fractions. Since the numerator is 5, I know at least one of them has to reduce. In this case, the 5 and the 5 reduce to 1. Make sure you bring that negative over with the bottom one. So now I can add my variables to the top and make my two factors. So 5k minus 6 is a factor, and k minus 1 is the other factor. Final answer. And then the last one, again, three terms, no greatest common factor. So I'm going to use my asterisk. 3 goes top left, top right. B goes in the bottom middle, so negative 29 in the bottom middle. And be careful, the top middle, you're going to multiply A times C, 3 times 18, which is 54. So now I'm looking for two numbers that multiply to give me 54, but add to give me negative 29. Yep, negative 2 and negative 27. So negative 2 times negative 27 multiplies to give me 54, but adds to give me negative 29. Again, when I look at my two fractions, I notice the numerator on both of them is 3, so something's going to reduce somewhere. The 3 and the 27 are both divisible by 3. So 3 divided by 3 is 1. Add your variable to the top. And then for your denominator, negative 27 divided by 3 is negative 9. Now I'm going to make my two factors. So 3p minus 2 is a factor, and p minus 9 is the other factor. Questions on this quick review? So factoring is something that in this class never really goes away. We'll continue factoring through almost every lesson. We'll factor every week in here. So if you've got problems factoring, you're not comfortable with it, come see me, shoot me a message. We'll schedule a time to work together until you're confident. Oops. All right, so for today's lesson, we are starting Unit 2, graphing quadratic functions. Quadratic function is a function that could be modeled by ax squared plus bx plus c, which is what we were just factoring. You might want to write, yourself a note that f of x is the same thing as y. So sometimes you'll see y, sometimes you'll see f of x. They mean exactly the same thing. There's only really one stipulation, a can't equal 0. You won't see that in here. So for it to be a quadratic, you have to have something x squared in your problem. Your graphs will look something like this picture here in the middle. It's called a parabola. Looks like a U. They could be flipped upside down. They could be stretched one way or another. They could be fat. They could be skinny. All that jazz. The domain of every quadratic function is all real numbers. So what that really means is we can input anything for x. So I can take this equation and I can plug any number I want in for x. That's a real number. And up until this point, you probably haven't had to deal with imaginary numbers. We'll get to that in a few weeks. The range for your function is determined by the y values. If your parabola opens down, well, let's go up. If it opens up, it's going to look like this. You have a definite bottom point. So that bottom point, whatever that y value is, you're going to plug in right here. So if it opens up, you're going to have y is greater than whatever the y value is of that bottom point. That bottom point you're going to learn today is called your vertex. If your parabola would open down, so your graph would look something like this down here, it's going to be the y value of that top point again, the y value of your vertex. And we will practice that. So some quick vocabulary. I'm going to be using your parabola as just the graph of a quadratic function. It looks like that U that you just saw. The axis of symmetry is going to be a line that divides our parabola into two mirror images. It's going to help us because we're going to reflect points, which means we can do half the work. If we can reflect points, we only have to find two of them, and then we can reflect them to the other side. The vertex is either that hill or the valley, depending on whether you have a U or an upside down U. It's just the point where the parabola intersects your axis of symmetry, the minimum or the maximum point on your graph. So here's a picture of a parabola that opens up. You're going to have a minimum value down here for your vertex. Your axis of symmetry is just this line going straight down the middle. Because, if I could draw a straight line. Because if I took a mirror, this line would exactly reflect on that one. And the same thing's true on your parabola here. If I took this purple line and folded my paper in half, every point would line up on the opposite side. And again, this one has a maximum value because that vertex up there is the highest point in your parabola or on your parabola. So we're going to talk about symmetry. Our axis of symmetry in this diagram here is this red line. That red line will always go through your vertex. So your vertex is right here, that bottom point. And then we're being told that this location here is 2 units away from my axis of symmetry, so I can mirror that 2 units away on the opposite side. Same way with the one at the top. 3 units away, I can mirror it 3 units away on the other side as long as I keep the same height. So looking at the diagram on the right, the first thing we're asked to identify is our vertex. The vertex is either the highest point or the lowest point. In this diagram, it looks like a valley, so we've got the lowest point, which is called a minimum. So my vertex is the ordered pair 1, -2. So remember, to find ordered pairs, you start at the origin, the middle, figure out how far left or right you need to go. In this case, you need to go right 1. And then how far up or how far down you need to go to get to the point you're looking for. In this case, we went down 2. Your axis of symmetry is always going to be x equals something. In this case, x equals, I need to go to the middle of this, right through my vertex, and right here would be my axis of symmetry. We always use it as a dotted line because it doesn't really exist on my graph. You just use it as a reference. So that is the line x equals 1 because it goes through 1 on my x-axis. It will also always match the x value of your vertex. So whatever number you have here, you can automatically bring it down for your axis of symmetry. Symmetrical points. We're going to locate 4 points just like we have on the graph on the left. The first two, well, let's not use those. We have 2 marked, but they're decimals. We're not going to use those actually. We're going to use this one right here with this one right here because they're at exact intersection. So this order pair is 0, -1. And symmetrical with it, so I'm 1 unit away from the axis of symmetry. I'm going to flip 1 unit away from the axis of symmetry is 2, -1. There is another set of symmetrical points right here and right here. See if you can list those 2 points over here for another set of symmetrical points. So hopefully you listed -1, 2, and 3, 2. So those are the 2 ordered pairs that I plotted that are symmetrical to each other in your graph. The last thing we need to identify is domain and range. Whoops. So as I said earlier, domain is always the same. It's always all real numbers. There is a shorthand way you can write that. The symbol for all real numbers is a capital line with an extra, a capital R with an extra line through it. I wrote it in parentheses in case you want to use that, or you can just write out all real numbers. So on your Unit 2 test, there's a question that gives you a graph just like this, asks you for the vertex, axis of symmetry, domain, and range. The domain for that question is all real numbers. So I'm telling you the answer for your next test. Domain is always all real numbers when you have a parabola. Your range, so for my range, I'm either going to have y is greater than or equal to if my graph opens up, or y is less than or equal to if my graph opens down. Do I have a parabola that opens up or opens down? Up. So I'm going to have y is greater than or equal to some number. So to find that number, I'm going to my actual graph and I'm going to look for the lowest point. The y value on this lowest point is going to be the number that I fill in right there. What number should I put? -2. So y is greater than, every y value has to be above this point. Is that true? Yeah. This is the lowest y value. A hint, this number that you fill in here will always match the y coordinate of your vertex. So we've got the x coordinate gets used for the axis of symmetry from your vertex. The y coordinate from your vertex gets used for your range. Questions on this slide? If I'm going too fast, just holler at me. So from a quadratic equation, we can automatically tell without graphing whether we're going to have a parabola that opens up like a U or down like an upside down U. There's one thing we have to look at. It's whatever number is in front of the x squared. So the a value. If this a value is positive, positive numbers make us happy, right? So positive numbers make us smile. Normally. So a positive a value makes you smile. This looks like a smile. It's going to open up. If your a value is negative, most of my students don't like negative numbers because at some point they leave out their negative, lose it. That makes them frown. So I always say, if you frown, it opens down. So if a is negative, you're going to frown, your parabola is going to open downward like an upside down U. So today we're going to look at graphing parabolas. We're going to learn two ways how to graph them. But either way, we've always got to begin with our vertex. So it doesn't matter what form we're looking at. The first point we always plot is your vertex. So we're going to learn about standard form, which is what we've been talking about, or vertex form, which is my favorite, because I can look at the equation and I can automatically write down my vertex. So anytime you see parentheses squared, when you're graphing, it's in vertex form. The only tricky thing we've got to watch out for, there's a negative in the formula, which means when I write down the sign of my vertex, it has to change. The k stays the same because it's plus k in the formula, but whatever number I take out of my parentheses has to change signs. Let's practice. So a vertex form, all I want you to do is write the vertex. So I'm just going to vertex h comma k. If I want h comma k, I've got h here with the opposite sign, k hanging out on the outside. So I need to switch the sign of -4. So I would write +4. And then my k value just comes down the way it is. So the vertex is automatically 4, 5, and I didn't have to do any work. See if you can look at this second one here and identify the vertex. You've got to change the sign on the inside. The outside stays the same. All right, so hopefully when you wrote your vertex, you took the 3, changed it to a -3, because you want the opposite sign from the inside. The k on the outside stays the same, so just -7 gets brought down. So anytime I ask you to graph something that's in vertex form, we can just automatically start off by writing our vertex using that formula. So looking at this next question, the first thing I want you to do is fill in maybe a little 1 right here. So there's a -1 sitting right there because of that negative sign. First step, we're going to identify the vertex and then we're going to graph it. So to identify my vertex, So I want the opposite sign on the inside, so I'm going from a positive 2 to a negative 2. So inside changes signs. The outside just comes down. So then positive 2 on the inside of my parentheses, when I bring it out for my vertex, changes signs. The number out of the end just gets brought down. Did I skip one? Oh man. All right, go back. Sorry. That's my fault. I must have hit the button too many times. All right, go back to this one since I skipped one. Our vertex is actually kind of similar, just off of the sides.
One side.
So here we have a negative 2 when we bring it out for our vertex, it's a positive 2. And then the number out at the end stays the same, so we've got a positive 1, we're going to bring down a positive 1. So our vertex is the order pair 2, 1. Again, my apologies for skipping to the next slide on accident. Then we're going to graph it. To graph the order pair 2, 1, I start at the origin. Since I have a positive 2, I'm going right 2. And then since I have a positive 1, I'm going up 1. So from the origin, right 2, up 1, that is my vertex. That's either going to be the top of the hill, if it opens down, or the bottom of the valley, if it opens up. Well, we're going to figure that out right now. So question number 2 says the direction of the graph. I want to know if it opens up or if it opens down. A is whatever number is sitting right here. We're looking at that number. It happens to be a 1 because there's nothing written there. Is 1 positive or negative? Positive. So my graph is going to open up. Positive numbers make us smile. So your graph is going to open up. It'll look like a smiling face. So next we're going to make a table of values. Remember, since we have that since we have this first point, we're going to make a table of values either looking at the x values to the left of the vertex or to the right. We don't have to do them both. So the x values I would use would be the first number to the left, which is 1. The second number to the left is 0. So these are the 2 x values I would use. You could go to the right of 2 and do 3 and 4. That would be okay. You can do all 4 if you want, but you don't have to. So to figure out what the y value is, if I plug in a 1, I'm going to the original equation, and I'm just plugging in 1. So 1 minus 2 squared plus 1. If you have one of my calculators like this, you can type it all in one line and just hit equals. So if you want to grab a calculator, you're more than welcome to. So if I take 1 minus 2, I get negative 1. Negative 1 squared is 1, plus 1 is 2. So I have the ordered pair 1, 2. So this is 1, 2. So I'm going to graph that ordered pair 1, 2 right here. Then I'm going to do the same thing with 0. I'm going to go back to the original and plug it in. So 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 1 is 5. So 0, 5 is my ordered pair. Start of the origin. 0 tells me I don't get to move left or right. The 5 just tells me to move up 5. So now I have half of my graph. Remember, through your vertex, you have what we call the axis of symmetry. So here's my line, or my axis of symmetry. What that means is I can just reflect every point over here to the opposite side. I could, if I wanted to, plug in 3 just like I did here to find those other 2 points, or I can just reflect them. I always find that reflecting is just easier. So if I look at this point right here, I have to keep the same height, so it's got to be on this line. And then currently I'm 1 unit away from the axis of symmetry, so I'm going to flip it. 1 unit away from the axis of symmetry will give me another point. So that's how this point was created. I promise you, if you take and you plug 3 in to the original equation, you're going to get 2. You'll get the same point if you plug it in. This is just faster because we don't have to plug anything in. And then same thing with this point here. I'm 2 units away to the left of my axis of symmetry. I'm going to flip it, go 2 units away to the right from my axis of symmetry. Again, you got to keep the same height. And there's my parabola. All I've got to do at this point is play connect the dots, just like so. Oops. We could work through and find more points, but 5 is all you need for algebra 2. Sometimes you'll get a graph where you can't fit all 5 points on it, and that's okay. Actually, I think there's at least one on your homework where you can only get 3 points on. That's okay. Questions on this one? So always make sure you're finding the vertex first. Double check. I know my graph should open up because we wrote that down earlier. My graph does indeed open up. Sometimes on a test, I've had people write that the graph opens down, and then when I graph it, it opens up. So you know one of the 2 things is wrong. All right, now on to the one I was so excited about earlier. So for this one, again, we're going to put that 1 there. For our vertex, we're doing the opposite of h, so we're doing the opposite of positive 2, which is negative 2. And then the k stays the same, the negative 1 just gets brought down. So our vertex, negative 2, negative 1. So start at the origin, go left 2 and down 1, that's my vertex. Then you're looking at the value of a, that's the first number out here in front. Since this time it's negative, negative numbers make us frown, your graph will open down. So we know our graph's going to look something like this. Again, it could be fat, it could be skinny, it could be tall, it could be short. We don't know what it's going to look like exactly. We just know it's going to open down. So now I'm going to make my, oh, I forgot to graph. Oh, no, I didn't. Gotcha. So now I have my vertex here. I get to pick x values either to the left or to the right of that point. So this x value here is negative 2. I can plug in negative 3 and negative 4 for my x values, or I can go to the right and plug in negative 1 and 0. Which 2 points am I going to plug in?
1 and 0.
1 and 0. Negative 1 and 0. I would do that too because 0 is easiest to plug in. So I'm going to the original. I have negative 1 times x, which is negative 1, plus 2 squared minus 1. Again, if you have one of my fancy calculators, you can type that all in at once. Let's see, negative 1 plus 2 is 1. 1 squared is 1 times negative 1 is negative 1, minus 1 is negative 2. So the ordered pair, negative 1, negative 2, will be what I graph. Negative 1. So right. I have some students who have already put their axis of symmetry on and start putting their opposite points, their mirror points that they're reflecting as soon as they graph the first one. That's okay. If that's what you want to do, then go for it. I just tend to do it again. So to plug in 0, I'm going to go back to the original equation. I'm taking out the x and I'm replacing it with 0. So now I have 0 plus 2, which is 2 squared, which is 4, times negative 1, which is negative 4, minus 1, which is negative 5. Ooh. So 0, -5. So there's my first 3 points. I get to reflect 2 of them across my axis of symmetry. Remember, your axis of symmetry will always go through your vertex, that first point that you're always graphing. And then I'm just reflecting. So this point right here is 1 unit away, so I'm reflecting it 1 unit to the left this time. This point down here, the 0, -5, I'm reflecting is 2 units away, so I'm going 2 to the left. And there's my 5 points required, and I'm just connecting. And there's my parabola, double check. I said originally my parabola should open down, and it does indeed. Questions on these two? So graphing in vertex form. All right, we're going to stop. This is the end of the first lesson. You have an assignment all the way at the end of your packet. You're going to do the front page. So the front page of the back page. So the last page in your packet, you're going to work on those first 3 circled problems. All right, so we're gonna go ahead and get started on the second lesson for today. So second lesson, we're going to learn how to graph from standard form, y equals ax squared plus bx plus c. That's what we've been using our asterisks to solve. So standard form is not as easy as vertex form because vertex form automatically gives us the vertex. So for standard form, you're going to use the numbers a, b, and c, well actually just a, b, to fill out this formula here. So x equals, so the x coordinate of your vertex is equal to -b divided by 2 times a. So that's going to give us the x coordinate of the original, or x coordinate of the vertex. Then we're going to take that x value, plug it back into the original for x to find the y coordinate. And that'll give us our vertex, and then we just continue the same steps after that as we did in the first lesson. So we would take the vertex, pick 2 points to the left or 2 points to the right to find those 2 x values to plug in. And there's still a note at the bottom. The sign of a still tells us if the parabola opens up or if it opens down. So if it's positive, your parabola will open up. If it's negative, your parabola will open down. So first question, we have to find our axis of symmetry. That formula is on your reference sheet that I'll give you for your next test. X equals -b divided by 2a. So if I look, a is 1, b is -8, and c is 14. We need the opposite of b. So if I ask you for -b, I want the opposite of whatever b is originally. So right now, b is -8. If I want the opposite of that, I want +8. Divided by 2 times a. The value for a, there's no number written there, so it's understood to be 1. You can write it in like I did, or you can just know that it's 1. So now I want to simplify this. Well, 2 times 1 is just 2. 8 divided by 2 is 4. So our axis of symmetry, sometimes abbreviated as AOS, axis of symmetry is x equals 4. That's also the x coordinate of our vertex. To find the y coordinate, we're going to take that 4 and plug it back into the original for x. Remember, f of x is the same thing as y. So y equals 4 squared minus 8 times 4 plus 14. Again, if you have one of my fancy calculators, you can type this entire thing in the way it is written. Make sure you're using parentheses. So when I plug that in my calculator, I got a value of -2 for my y. So that means my vertex is the ordered pair 4 from my axis of symmetry. When I plug that back in, I got -2, which means my vertex is at the ordered pair 4, -2. So to graph that, I'm going to the origin, the middle of my coordinate plane, going right 4 and down 2. Question 3 wants to know the direction of my graph. I want to know if this opens up or opens down. Up. So A is +1. Anytime it's positive, we smile. So it's going to open up. It's going to look like a smiley face. Then we need to make a table. Again, we're only going to do one side of our parabola, and then we're going to reflect to find the other side. So we get to pick x values that are either to the left of this or to the right of this vertex. So the vertex, the x value of my vertex is 4, so I can pick 3 and 2, or I can pick 5 and 6. It does not matter which 2 you pick, as long as both of them are from the left or both of them are from the right. So let's do 3 and 2 because they're smaller. And if you still have your work from up here typed in your calculator, you can just edit those two 4s and change them to 3s. Hit equals, and your calculator will calculate that for you. Or if you are not, you can type it all in again. So if I was typing it all in again, it's minus. This is what I would type in. So 3 squared minus 8 times 3 plus 14. Again, if you've got one of my calculators, you can type that all in one line. Also, remember, you cannot use your cell phones as a calculator on your test, so you better practice using a calculator so you're not lost on day one. When you plug this into your calculator, you should get a value of -1, which gives you the ordered pair 3, -1, which is that point right there. Then I'm going to do the same thing with my x value of 2. Again, if I have a calculator that I can just edit things in, I would just edit it instead of typing it all in again. If you're typing it all in again, this is what I would type in. So 2 squared minus 8 times 2 plus 14. You're going to hit equals. That should give you a value of 2. So your ordered pair 2, 2. To graph that, I'm going to the origin, I'm going right 2 and then up 2. And that is half of my parabola. Remember, your axis of symmetry goes through your vertex, so I'm going to draw my dotted line for my axis of symmetry. And then I'm going to reflect the 2 points that I just plotted. So I'm going to reflect 3, -1. So currently it's 1 unit away from the axis of symmetry. So I'm going 1 unit to the right and I'm putting my reflective point. Then for 2, 2, I'm going to be 2 units away from the axis of symmetry. So I'm going 2 to the right and I'm putting my 5th point. Then I'm going to play a little game of connect the dots. Make sure you got arrows on both ends because your parabola does continue on forever. We could plug in more numbers and get more points. But again, for this class, I just need to see 5. Unless they don't fit on your graph, and then 3 is okay. questions on this one? Oh, no. All right, the next one, negative x squared plus 2x plus 2. First thing we need to find is the axis of symmetry so that we can use that x value to find the vertex. So axis of symmetry, we know the formula is x equals the opposite of b divided by 2 times a. Keep in mind, in this case, a is -1, b is +2, and c is +2. Take a minute and see if you can find the x value of your vertex, which is the axis of symmetry. So hopefully when you simplify that, you got a value for your axis of symmetry of x equals 1. So now to find my vertex, I'm going to take that 1 and I'm going to plug it back into the original equation. So -1 times 1 squared plus 2 times 1 plus 2. Again, make sure you're using parentheses when you're typing this in your calculator. So after typing that in my calculator, I get a value of 3, which tells me my vertex is at the ordered pair 1, 3. So I'm going to go ahead and graph that. Remember, your vertex is always the first point that you graph. So 1, 3 to the right, 1 from the origin, and then up 3. Direction of my graph, I have to decide, is A positive or negative? Negative, which means my graph is negative, so I frown, which means it opens down. So my graph will look something like that. So now I get to pick values for my table. So the x coordinate of my vertex was 1, so I can go to the left of 1 and plug in 0 and -1, or I can go to the right and plug in 2 and 3. It does not matter. So I would probably plug in 2 and 3 because they're both positives. I don't want to deal with that -1. If you do 0 and -1, you'll get the same exact graph as I would. Did you do it? That's fine. So it doesn't matter. All right, so let's see. -1. All around or plus 2. So when I plugged in 2, I got 2. When I plug in 3, I got -1. So now I'm going to graph those to 2 and 3, -1 to get half of my parabola. Then I'm going to go ahead and draw in my axis of symmetry. Remember, your axis of symmetry goes through your vertex every single time. And we draw it as a dotted line because it's not technically part of the parabola. It's just a reference point that we use. So then I'm going to reflect my points. If I look at 2, 2, it's 1 unit away, or 1 unit to the right of my axis of symmetry. So I'm going to keep the same height. I'm going to go 1 unit to the left to get my 4th point. To get my 5th point, I'm going to go to 3, -1. It's 2 units to the right of my axis of symmetry, so I'm going 2 units to the left, and I'm plotting my 5th point. Then I'm going to play connect the dots to make my parabola. Make sure arrows on both ends because this graph continues. We just stopped graphing, and that's okay. Questions on this one? For this one, the first thing we want to find is our axis of symmetry. The formula for our axis of symmetry, x equals the opposite of b divided by 2 times a. What do you notice about this equation? It's missing a term. You have to be able to decide what term is missing. So it is the b value that's missing. If it helps you to rewrite it as 2x squared plus 0x, that term's the one that's missing, -1, so you can see it, by all means, go ahead and do it. So the b value of that linear term was missing, so we just filled it in. There are none of them, so I put 0x. So when I fill out for my axis of symmetry, I need the opposite of b. Well, the opposite of 0 is still 0. Divided by 2 times a. A is 2. So 0 divided by 4, which is still 0. So my axis of symmetry is x equals 0. That x value is also the x coordinate of my vertex. So I'm going back and I'm going to plug in 0 to find the y value of my vertex. So 2 times 0 squared minus 1. Well, 0 squared 0, 0 times 2 is 0, minus 1 is just -1. So my vertex is the ordered pair 0, -1. I want you to decide on your paper. I want you to write whether the graph opens up or if it opens down. So check out that a value. Yep. So since it's positive, it's going to open up. Positive numbers make us happy, so we're going to smile. For my table, oh, I didn't graph my vertex. To graph my vertex, I'm starting at the origin. The 0 tells me I do not get to go left or right, but the -1 tells me to go down 1, so this point right here is my vertex. I want you to fill out your table, so you can either pick to plug in -1 and -2, or +1 and +2. If I was making a suggestion, I would say the positive parts. So take a minute and see if you can find those other 2 points. If you're feeling brave, go ahead and graph them and reflect to see if you can get your final graph. So I plugged in 1 and 2, and I plugged in 1, I got 1. So the ordered pair 1, 1 was the next point that I graphed. And then the second point I plugged in 2 and got 7. So the next point would be 2, 7. Then I'm going to draw in my axis of symmetry, which is actually right along the y-axis. And then I'm going to reflect. So the point at 1, 1 is 1 unit to the right of my axis of symmetry. The second one is 2. So I'm going to the left, and then I'm going to connect them. Oof, that was rough. So there's my final graph. Again, I'm always double checking to make sure. I said my graph would open up, and my final graph does indeed open up. Questions on how to graph when you're given standard form? So now you have 3, I believe, problems on the back page. 1, 3, and 6. So you're going to follow this same process. First thing you're going to do is find the axis of symmetry, because that tells you the x-coordinate of your vertex. Plug that back in to find the y value of your vertex. Make yourself a table, reflect your points, connect the dots, and you are done. If you have questions, please let me know.